basically what I wanted to do, the only thing that I wanted to do today was give you a sense of what the innovation is without boring you with a bunch of unnecessary stuff. Show you what it's capable of doing, and then now I'm just going to show you basically how it's put together. Do you have a good view from there?
What would you like me to?
Well, I just want them to be able to see this. This is the part that would interest them the most, okay?
Absolutely.
So the coils are supplied by our supplier in Toronto. The magnets are supplied by our magnet supplier in Pennsylvania. You guys would potentially integrate the magnets into the rotor. The coils, as I've done it here, the rotor basically slides between the cores here, and the coils slide into basically a jig. Okay, so there's a jig that holds the coil in place, and then the bearings which hold the drive shaft in place, and this prototype has 3 coils in it, but it's made to house 12. Okay, and if this is about a 1 kilowatt generator size. If you wanted, and this can be cascaded essentially, so if you wanted a 2 kilowatt, you could add another rotor, a 3 kilowatt, and you could potentially go to, 5 rotors to get a 5 kilowatt, or you can just increase the strength of the magnets, and then you can get more power out of the system as well that way. And this design is good from a user point of view. Okay, this is the core out of a car alternator. This is basically the design that's in all the generators, pretty much all the generators that are used commercially, and this is a 3-phase winding, but it's essentially a single winding, okay? If the generator, if there's a short in one of the windings, if there's a problem with the winding, basically you have to take the entire generator out, you have to dismantle it, you have to take the windings out, send it out to be rewound, and it's a huge issue. I mean, if you can imagine a wind turbine, for example, that if they have a problem with their generator coils, they have to physically take the generator out of the wind turbine, take it down, put another one up there. It's a huge problem. This design is different in that if this coil that's slid into that jig, if it has a problem, if it has a short, if it gets burnt out, if something happens to damage that coil, all you have to do is loosen the jig, pull the coil out, put another one in, and you're good to go. So from a repair standpoint, you can basically, you can take coils out of a ReGenX generator while it's running, if there's a problem with that coil, and replace it with a new one with 0 downtime. And in the generation industry and the repair industry and so on and so on, that's a colossally advantageous thing, because again, I was a motor technician across the river in a paper mill, and my job was to take motors motors and motors at that time, take them out from where they were used to drive paper machines. And we're talking about motors that are as big as a van. And take them out, take the housing out, take the winding out, and send it for rewinding. The motor would be out of commission for at least a month. And then you'd have to put another one in, or you'd shut down that entire system that depended on that motor. With a ReGenX motor or generator, if something happens to one of the coils, it stops functioning, you just pull it out and put a new one in. And aside from the operational advantages, making a ReGenX generator or a ReGenX motor is a really simple thing to do as well, because once you have the rotor in place and the jig in place, you basically just pop the coils in and you're good to go. Okay, that's it. You guys want, you can have a seat now if you